Good morning once again. Let us solve some numerical problems. When 0.15 kg of ice at 0 degree Celsius is mixed with 0.30 kg of water at 50 degree Celsius in a container, the resulting temperature is 6.7 degrees Celsius. Calculate the heat of fusion of ice. Heat of fusion of ice, or you can call heat of melting of ice. So the mass of ice is 0.15 kg, 150 gram. It is added with 300 gram of water. 300 gram of water at 50 degrees Celsius. Temperature of ice is 0 degrees Celsius. So here, when the water is at 50 degrees Celsius, ice is added to the water, then the water loses heat, the ice gains heat. So heat lost by water at 50 degrees Celsius is equal to heat gained by ice at 0 degrees Celsius. Okay, the heat gained by ice at 0 degrees Celsius again has two parts. First, ice has to convert it into water at 0 degrees Celsius. So first we have to calculate what is the heat required to convert ice into water of mass 0.15 kg. Then what is the heat gained by water until it reaches the final temperature 6.7 degrees Celsius. This is how we are supposed to solve. Now we are using again principle of calorimetry. So let us first write what are the given things. Mass of ice, let us take it as M1 is equal to 0.15 kg. Temperature of ice, T1 equal to 0 degrees Celsius. Then next, mass of water, M2 0.30 kg. Temperature of water, Celsius. We will call it as T2. 50 degrees Celsius. Final temperature, when it is in equilibrium. Let us take it as T equal to 6.7 degrees Celsius. So first we calculate heat lost by water. Heat lost by water. We will take it as Q2. Heat lost by water as Q2. Q2 is equal to M2, mass of water, into specific heat of water is given here as W, into T2 minus T, because temperature here is 50 degree, that is initial temperature, it loses and finally it becomes 6.7. So T2 minus T. So this is heat lost by water. Now we will calculate this. Is equal to mass. Mass is 0.3 kg into specific heat 4186 joule per kg per kg into 50 degree minus 6.7. So if you calculate this using calculator, quickly you get the answer. Q2 is equal to 54376.12. This much is the heat lost by water. Now, heat required required to change state of ice into water we will calculate. Heat to change phase of ice into water is equal to Q, mass of water into latent heat of fusion. Latent heat of fusion. Mass of water into latent heat of fusion. Now, heat gained by water. Heat gained by ice water. Heat gained by ice water. We can calculate now. Now, heat to change phase of ice into water is equal to mass of ice into latent heat of fusion. Mass of ice is given here. Mass of ice is 0.15 kg. So it becomes 0.15 into LF. So we are asked to calculate what is LF here. Next step, heat gained by ice water to reach final temperature. Now once ice is converted into water, until it reaches 6.7 degrees Celsius, what is the heat required? Heat required to reach this temperature 6.7 from 0 degrees Celsius. That's what we call as heat gained by ice water to reach final temperature 6.7. That is equal to M, we call it as Q1. M1, that is mass of ice, that is equal to mass of water now. M1 into SW, that is specific heat of water. Now it is already converted into water, into T, final temperature, minus T1. Final temperature minus initial temperature T1. So this becomes 0.15 into 4186. You can take 4200 for convenience, 4200 into temperature. Final temperature is 6.7 minus 0 degrees Celsius. So if you calculate this comes out to be, quickly we can write 4206.93 joules. Now we are using principle of calorimetry. Heat lost by hot water at 50 degrees Celsius is equal to heat gained by ice to reach final temperature. Heat gained by ice to reach 6.7 degrees Celsius. Now this you can call equation number 2. This is equation number 1, this is equation number 2, and this is equation number 3. Equation number 1 is equal to equation number 2 plus 3. So we can write here equation number 1 is equal to equation number 2 plus equation number 3. Q2 is equal to Q plus Q1, that's the meaning. Q2 is equal to Q plus Q1. Heat lost by water at 50 degrees Celsius. Q2 equal to heat required to change the phase of ice into water. Mass into latent heat of fusion, 0.15 into 11, plus heat required to change, heat required to raise the temperature of ice water up to 6.7 degrees Celsius. That is Q1. Q2 is equal to Q plus Q1. If you substitute this, then we will be able to solve for LF. So by the principle of calorimetry, heat lost is equal to heat gain. So heat loss is 54,376.14 joules is equal to heat gained by ice to convert it into water, 0.152 latent heat of fusion, plus the heat required to raise the temperature of ice water at 0 degrees Celsius to final temperature 6.7 degrees Celsius. We have calculated 420706.93. So using this we can calculate what is LF. Therefore LF is equal to 54,376.14 minus 4206.93 whole divided by 0.15. So if you calculate this, it comes out to be 3.34 into 10 raised to 5 joules per kg. Joules per kg. This is latent heat of fusion. If you calculate in the calories, it comes out to be 80 calorie per gram. 80 calories per gram or 80 kilocalorie per kg or 80 kilocalorie per kg. In some numerical problems, question will be asked on the calculation of calorie. That's why I have written calorie. Okay. This is how one has to use the principle of calorimetry and the concept of latent heat. Then we will be able to solve the problem. Now let us solve one more problem. Look at this another problem. Calculate the heat required to convert 3 kg of ice at minus 12 degrees Celsius kept in a calorimeter to steam at 100 degrees Celsius at 1 atmospheric pressure. So there is ice, 3 kg ice. 3 kg ice. It needs to be heated strongly so that it reaches not only 100 degrees Celsius and gets converted into steam at 100 degrees Celsius. So initial temperature is minus 12 degrees Celsius. It has to be heated strongly. So that it first gets converted into ice water, then ice water into water, and it has to increase its temperature up to 100 degrees Celsius, boiling water, then boiling water has to be converted into steam at 100 degrees Celsius. What is the total heat required? This is the question. So it has got 4 parts. First, the 3 kg ice at minus 12 degrees Celsius has to be converted into 3 kg water at 0 degrees Celsius. Okay, then how much is heat required? So first we will calculate that. So first, total heat required to convert 3 kg ice at minus 12 degrees Celsius to steam of same amount at 100 degrees Celsius. This is Q. This Q is equal to Q1, that is heat required to change. Heat needed to change ice heat required to increase, not change, heat required to increase ice at minus 4 degrees Celsius. 2. Ice at 0 degrees Celsius. This is Q1. Then Q2. Ice at 0 degrees Celsius must be converted into water at 0 degrees Celsius. Mass of ice into latent heat of fusion. Latent heat of fusion. That's what we will write as heat required to convert 3 kg ice at 0 degrees Celsius into 3 kg water at 0 degrees Celsius. Understand the point here. Here, initially the ice is at minus 4 degrees Celsius. It has to be increased to 0 degrees Celsius first. Still it is in the solid state. So this Q1 is calculated as mass of ice. We'll take it as mass of ice as M1. That's it. Mass of ice Mi into specific heat of ice. Specific heat of ice is given here 2100 into change of temperature. Final temperature is 0 degrees Celsius. 0 degrees Celsius minus initial temperature is minus 4 degrees Celsius. 0 minus of minus becomes plus 4. So we write it as Mi. What is Mi? Mi is 3 kg and specific heat of ice is 2100 into minus of minus 0 minus of minus plus 4. So it becomes Q12. So this is Q1. Then Q2, mass of ice. Mass of ice is how much? 3 kg into latent heat of fusion. Latent heat of fusion is given 3.35 into 10 raised to 5 joule per kg. Then Q3, see the interesting part. Now it is converted into water at 0 degrees Celsius. Now water at 0 degrees Celsius has to increase to water at 100 degrees Celsius. So mass of water into specific heat of water into change in temperature. Change in temperature is 100 degrees Celsius minus 0 degrees Celsius. From 0 degree water, it has to reach 100 degree boiling water. How much heat is required? This is what I am writing. Heat required to increase temperature of 3 kg water at 0 degrees Celsius to 100 degrees Celsius into water. So this I can write it as 3 into 4186 into 100. Now last step. Water is there, now boiling water is there at 100 degrees Celsius. It needs to be converted into steam at 100 degrees Celsius. We have to consider latent heat of steam. Q4. Mass of water into mass of water or mass of steam into latent heat of steam. Latent heat of steam I will write it as latent heat of vaporization. L steam. This is 3 kg into 22.6 into 10 raised to 5 joule per kg. Now total heat, now I can write therefore total heat required Q is equal to Q1 plus Q2 plus Q3 plus Q4. We have to add all these 4. Once we add all these 4, then we get the total result. So total heat required Q is equal to Q1 plus Q2 plus Q3 plus Q4, means total heat required to convert 3 kg of ice at minus 12 degrees Celsius into 3 kg of steam at 100 degrees Celsius. Q is equal to, using these steps, we can write it. Q1 is 75,600 Joule. This is Q1, 75,600 Joule, Q1. Q2 is 10 lakh 5,000 joules. 10 lakh 5,000 joules. 10 lakh 5,000 joules. Ten lakhs 5,000 joules. Q2 is lakhs. So you can write stepwise. It becomes 10 lakh 5,000 joules. Q3 when you calculate, here it comes out to be 12 lakh 55,800 joules. Then Q4 is calculated to be 67 lakh 68,000 joules. These are all in joules. So if you add this, Q is therefore equal to Q1 plus Q2 plus Q3 Q4. If you add all this, then we get the result. 8 plus 6 14, carry 1. 9 plus 5 14 plus 10 24, carry 2. 8 plus 5 13 plus 7 20. 6 to 9 9 to 11, carry 1. 6 plus 3 9. 91 lakh 4,400 joules. So therefore total heat required can be written in terms of scientific notation as 9.1 into 10 raised to 6 joules. This is how we need to calculate. So solve the problems from simple problems you can solve from the net. Solve the problems from different sources from the textbook. These will be very important not only from the point of view of your 11th class examinations, but from the point of view of your all competitive examinations like UPSC, JEE, NEET and all such questions. Simple questions will be asked, not so complex questions. Usually questions will be asked in the for the calculation of calories. Calorie will be easier to calculate, that is in terms of CGS rates. Okay, thank you, have a nice day.